Hi, I'm Dr. Papia Bhattacharjee. In this problem, we are given two functions f and g. Notice that f is a linear function and g is a quadratic function. We have to find the sum of squared errors for f and g for these given points. There are 5 points that are given to us. And then we have to determine which of these two models, this is a linear model and this is a quadratic model, which one will be a better fit for these points. Okay, so let me first remind you how to compute this sum of squared errors. Okay, suppose you have a function f and you're given a bunch of points, and say the points are x1, y1, x2, y2 up to xn, yn. Then the sum of squared errors, like the name suggests, first you compute the error, which is the function value at the point minus the actual y value. So that's the error, then you square it, and then you add all these terms. That's why it's a sum of squared errors. So you do it for each point. The last one is f of xn minus yn squared. So that's the formula to compute the sum. Now, to compute this sum for f and g, let's make a table first. So we will plug in our x values and the y values of the given points, and then we will compute the function values for f and g for both models. Okay? So pick a calculator, whatever calculator you have, and let's first write down the x values. So we will have -3 and the corresponding y is 2, then -2, 2, -1, 4, 0, 6, and 1, 8. So those are our points. Okay? And now we will plug in the x value in the linear model given by the function f. So let's start with that. So first we will plug in -3 for x in this expression. So you plug in 1.6 times -3 plus 6, and you get 1.2. Okay. Then do the same, 1.6 times -2 plus 6, 1.6 times 1 plus 6, that's 7.6. Okay. So those are the values for the linear model. Now for the quadratic model, we take the second expression, the expression for g, and plug in the x values again. Okay, so let's do 0.29 times -3 squared plus 2.2 times -3 plus 6. And we get 2.01. Okay, now keep doing that, except instead of -3, you put -2. And for the last one, you plug in 1 instead of x, and you have 8.49. So we have all the function values for both functions given these x values. Now we compute our sum. So let's compute sum of squared errors for the linear model. So for f of x, so what is the sum? Look at the formula here. You have to take the difference of the two y values. So the f of x and the y, the difference of these two values. Okay, so we have 1.2 minus 2 square. Look at these two. Then same way, 2.8 minus 2 square plus 4.4 minus 4 square plus 6 minus 6 square, and finally 7.6 minus 8 square. So let me do this calculation using a calculator, and I'll be right back. So it turns out that the sum is 1.6. Okay, now we have to do the same thing for g of x. So for gx, let's write down the sum. Now we have to consider this row for g and the actual y value and take the difference and then square them and add them. So we have 2.01 minus 2 square plus 2.76 minus 2 square plus 4.09 minus 4 square plus 6 minus 6 square, and finally 8.49 minus 8 square. And again, I need the calculator to calculate this, and I'll be right back. So we input all the values, and the sum is 0.8259. Right, so we have computed both sum of squared errors for the linear model and the quadratic model. Now finally, we have to decide which model will be a better fit for these points. Now look at the numbers. These are errors. So we want the error to be less, right? And you see this number for g is smaller than the one for f. So the error for g will be less than the error for f. So obviously g will be a better fit. So since 0.8259 is less than 1.6, the quadratic model is a better fit. And that concludes this problem. Thank you.